Welcome to section 6.2. We're going to talk about what are called sum and difference formulas for sine, cosine, and tangent. Sum and difference formulas are going to help us solve problems that do involve sums and differences of angles, and we can actually get some exact values, that is, values in terms of radicals, fractions, and so on, for angles that are not our standard 30, 45, and 60 degree angles. So it would be useful to have something that would allow us to evaluate something like sine of 75 degrees or the cosine of pi over 12, where we can have a formula that will break apart the original formula. In fact, that is the purpose of the sum and difference formulas. And there's 6 of them, as you can see right here. The sine of u plus v. You have to note that we're not multiplying sine times u plus v, and I've been attempting to emphasize with all of you that that's not the case. You don't multiply sine times u plus v. It is the sine of the angle u plus v. And it turns out that in order to get the sine of the angle u plus v, in fact, it will be the same thing as the sine of the first angle u times the cosine of the angle v plus the cosine of the angle u times the sine of the angle v. So in fact, it becomes a sum of a product of two different things. Sine of u minus v is very similar. We take the sine of u, multiply it by the cosine of v, but this time subtract the cosine of u plus the sine of v. The cosine of the quantity u plus v would be cosine of u times the cosine of v, this time minus the sine of u times the sine of v. And the cosine of u minus v is the cosine of u times the cosine of v plus the sine of u times the sine of v. And it would be really helpful if there are no other identities that you will memorize, is to try to memorize these functions right here, because this will be really useful to you when we develop a few other formulas in the upcoming section. The other ones are tangent of u plus v and tangent of u minus v. For tangent of u plus v, we're going to take a fraction that consists of the sum of the tangent of u plus the tangent of v in the numerator over 1 minus the product of tangent of u times the tangent of v. And when we take a difference of tangent of u minus v, we will be taking the difference of tangent of u minus the tangent of v divided by 1 plus the product tangent of u times tangent of v. So we'll use each of these right here. Let's actually start off with that first formula right there. How would we evaluate the sine of 75 degrees? Well, according to the way that I had written it in the previous slide, we say, well, all right, let's treat it this way. Sine of 75 degrees would be the same thing as the sine of 45 degrees plus 30 degrees. Now, we can't take the sine of 45 degrees and add it to the sine of 30 degrees. That's not what this says at all. We have to go to our formula right here for the sum of two angles. So that's what we'll do. What we're really going to say then is that in order to evaluate the sine of 45 degrees plus 30 degrees, we would have to take the sine of 45 degrees multiply it by the cosine of 30 degrees, and then add that to the sine of 30 degrees. Times the cosine of 45 degrees. I know I'm kind of reversing that from what it says right here. We would take the cosine of 45 degrees times the sine of 30 degrees in this formula, but it seems to make sense that we're going sine cosine. So what are we going to do? That means that we're going to have to take the values individually. So this is where you want to remember. What was the sine of 45 degrees? Well, that's right. It was radical 2 over 2. And the cosine of 30 degrees was square root of 3 divided by 2. The sine of 30 degrees, well, if you don't remember it, that's 1/2. And the cosine of 45 degrees was the same as the sine of 45 degrees, so that is the square root of 2 divided by 2. Alright, so putting this together, we actually get the following value. The square root of 6 divided by 4 added to the square root of 2 divided by 4 So we combine that as a single fraction. We call our exact value of this expression the square root of 6 plus the square root of 2 all divided by 4. And this would be the way that we would express that exact value here for the sine of 75 degrees. All right. We were also asked to evaluate this cosine of pi over 12, so let's use the formula that we had over here. The way that we split it up was to divide it up as a difference of the angles this time. Come on now. Come with me. Here we go. So we divided it up this way by saying, well, the cosine of pi over 12 is the same thing as the cosine of pi over 3 minus pi over 4. Now, I recognize that people do sometimes have a little bit of difficulty visualizing this sort of thing. So let me rewrite it for you just to show you what pi over 3 minus pi over 4 will do. Because we have fractions, we would have to subtract over a common denominator. And in this case, the common denominator of pi over 3 and pi over 4 is 12. So in fact, we are saying that we're taking 4 pi over 12 and subtracting from it 3 pi over 12, which is how we're saying that the cosine of pi over 12 is the same thing as the cosine of pi over 3 minus pi over 4. All right, so bearing that in mind, that's pi over 12, pardon me, right there. So bearing that in mind, let's evaluate this. Remember, it is not the case that we multiply cosine times anything. Here we're saying it's the cosine of the difference of these two angles. So we're going to have to use our formula here at the bottom for the cosine of u minus v. So using that, we're going to have, in fact, the cosine of the quantity pi over 3 times the cosine of pi over 4, and we're going to subtract from that the sine of pi over 3 times the sine of pi over 4. And you notice that I just made an error here. You see it? Yeah, remember, if it's cosine, that means we change the sign in between these two. So this should be plus, right? If it's subtraction and cosine, you use a plus between these two values. That's the way I kind of remember it. So, all right, let's take our cosine of pi over 3. Cosine of pi over 3 is 1/2. And the cosine of pi over 4, well, if you remember it, that is the radical 2 divided by 2. All right. Sine of pi over 3 was the radical 3 over 2 value. And the sine of pi over 4 was again radical 2 over 2. And so we end up with the square root of 2 divided by 4 plus the square root of 6 divided by 4. So combining all of that as a single fraction, we get the square root of 2 plus the square root of 6 divided by 4. Kind of interesting that we're coming up with this value twice. I wonder if you can show me why that would be. In any case, we'll go through a short proof of our last formula right here in order to verify this for you. You should see this at least once. See you in the next video.